Hello everyone and welcome back. It's been a while. I hope everyone's been having a relaxing time the last few weeks, started the last week or so, and that people have had some nice food to eat and good company. And yeah, I'm just going to basically dive right in. It's been a while since I've done a bit of streaming, so nice to get back into that. And yeah, wishing everyone a happy 2026. We'll see where it takes us. So where I had left us off last time was I just implemented this idea on error handling, catching errors as booleans, which is the first level of the error handling. I'm going to park that for the moment before I jump into catching errors as errors or exceptions as exceptions, where I just did a quick recap of the last video that I did, and it looked like I was going to look at this idea, the backporting, short circuiting of conditional statements, and I'm going to show you why that might be necessary and desirable. So I was just looking around the files earlier, so we can go into our, let's see which file would be the best. So it is notably relevant in this file, in the features to do with catching exceptions as booleans as we implemented in the last stream. So here we can see we have a test for when a property is not found in an object. Do I call them objects in this language? It's been a while since I've worked on this project, so I think these are still called objects. And so the idea is if we try to access a property that doesn't exist, so we can use this question mark on its own as an operator to catch an exception and turn it into a boolean. And we can see up here it works out as expected. So if the object contains a property with this key, then we'll check the sentinel value okay, and then if it's there, we'll print v. What will happen down here though is we'll access b. That will generate an exception that'll get caught immediately. We'll check OK, and OK in this case will return false, and so we'll print nothing. And that's all good and well and good, and what we expect and want. Where it becomes a little trickier is if we want to check some property of the value that we retrieved. So in this case, we want to say if the value is okay, or if the value is present, shall we say, and the value isn't equal to 0, then we'll print the value. Otherwise, we'll print nothing. So we'll print nothing if the value doesn't exist or if the value of it is 0. Now let's see what will happen in that case. And we can just empty this object. So property not found, what do we call this? And condition. We'll say property not found and what we would like this to be, well, we'll do 2 tests actually, or 2 sequences, and we will reintroduce a here. Well, no, because it only really matters if the value doesn't exist. And so in theory, we would want this to say nothing because B isn't present in the first place. But what we'll see here is when we rerun the tests is that because we're not short-circuiting, oh, well, that's something different. That's just me not using the language properly. But we'll see here that when this value doesn't exist, OK will be set to false and the value V will be set to null. And that'll always happen if an exception happens on the right hand side of the catches boolean operator. And so we'll want to print as nothing, but because null and int are two different type spaces essentially, then they can't be compared. Now, that isn't so much of an issue. And in fact, there could be any number of errors that we have on this right-hand side when OK is false. But the point is that we don't want to evaluate this right-hand side when the value is false anyway, because the assertion is kind of moot. We're only wanting to check this side if the value was OK in the first place. And so what we need for that is short circuiting, which is the thing that is missing in this scenario. So let's go take a look at implementing that. So we'll go and open the mod file and we'll jump to the implementation of and. And so the thing about the operators is that all of them at the moment, the binary operators, and I think the other operators as well, but particularly the binary operators, are all implemented so that the left-hand side and the right-hand side are evaluated before the operator is applied. And that makes sense for most operations, I would say, because they're not short-circuiting. So the arithmetic operators, the comparison operators, and so on. But this is a special case with the Boolean operators. So essentially what we're going to do is just separate this out, and we're going to create a new section called apply Boolean operation if the operation is and or. And so let's see how we match on that first. So we will do a match on OP here, I guess. Will we do try apply Boolean operation? Because the only, not issue, but the only niggly bit really about this section is that we can duplicate logic, and that can very mildly affect runtime. In general, we don't want to repeat operations even if they're very low overhead. But in this case, let's see. Now, I'm also very rusty with this. It's been a decent amount of time since I've taken a look at this project, so we'll have a little patience around it. So if it's one of those two operations, then we'll do it this way, and we'll have a return. Yeah, I guess we'll do it like that. We'll do apply Boolean operation. And so we're basically just going to remove most of these checks. Are any of those going to need to be changed into short circuiting either? So we've got some, we've got reference equality. No, No, it's basically just the ands and ors. And of course, it's the binary boolean operations and not the unary ones. But that's okay. I'm going to put down here. Now, we shouldn't get to this point because we're kind of gated by this area, but just in the off chance that we get here, we'll put in a little panic. Now, in general, we want better error handling than just putting panics in the code base, but in this situation in particular, where we're kind of saying it shouldn't be possible to make it to this point by the structure of the code that we have so far, then I think we're okay to work it like that. And we're going to do the same here, but we're actually going to handle the cases specifically so that we have everything covered, all the different variations of our variants of that enum. And so we're going to want to find that error as well. And we're going to want to bump the version. Now that we're in 2026. Oh, I need to do it like that. I'm going to call this boolop. And where else is that handled? I think it's in main. And actually I need to bump that too. So let's try that. And are both of these used? Int overflow isn't being used, so we can get rid of that. And so what we're going to want to do here is we don't have RHS val at this point, so we're going to instead want to take RHS itself. Now, I don't actually know what the type of RHS is here, and I don't have an IDE, so I'm going to just try and let the compiler tell me what that expected type is. So first of all, we'll change, let's see, 1013. Yeah, that should be a semicolon. I can't apply that to... Can I do it like that? I guess so. In general, I don't want to be dereferencing things, so maybe I can do it like that. But the mismatch types are the main things that I'm interested in. So I have a box. So I have a value. I want one of these box types. I need to look that up. It's been a while. Like I said, since I've looked at this. So is it an expression? I guess so, yeah, because it's a raw expression and a location. And in general, I'm using type aliases. It's funny that it won't use the type alias there, I guess, because it gets carried around. No, it is a bit funny, I feel like. Okay, what we'll do, we can rejig these bits a bit now. Well, first what we'll do is we'll evaluate the type of LHS. And that will need to be a value bool. I think I can rejig it as that. How can I do if lets with a type assertion? I might have some functions for getting values of a specific type. Yeah, so evaluate expression to a certain type. And that's if we're matching and evaluating in the same statement, basically. So what we're gonna want to do here is, do something like that. So we are checking the type of the value, and then if it's not what we expect, we will return an error. And so what's the name of our new value? Well, down here I just call them A and B, so it's not the greatest, but maybe I just do that here. And so once we have our first value, we can evaluate whether we're going to continue the function based on that. So we're going to do match operation. If it's an and, then we say what? If a if it's not a, then we return, okay, false. Otherwise, we continue with the evaluation. Yeah, and I suppose I'll fill out both blocks and then kind of unroll them if they can be optimized a bit further in terms of code. So let's do it like that. So if not A, then we'll return. Otherwise, we are going to evaluate the right hand side value. And then we're going to do a similar let B is equal to that. And then if so we'll only want to return true if, let's see, we'll just write it out explicitly first and then we can shrink it if we need to. So we can swap those. So we can do that. Do we have context and scopes in here? We don't. We'll need to take those. And I don't think there's anything else I need from that. So this is going to be the same, more or less, except, well, first of all, we need to fix that so that's the right-hand side val. We'll need to correct that a little bit. But let's see about this first. In this case, we're just returning the value of A as well. Are we? So in the first case, we're saying if the first value is false, then it doesn't matter what the right-hand side is. But if it's true, then the right-hand side is going to give the result of the whole expression. And that is correct for and or. So let's just double check with the tables. I mean, it's fairly elementary stuff, but when you haven't done it in a while, it's not a bad idea to double check your work. So in the case of and, we're basically saying we eliminate this case, and so the result is tied to the right hand side, which it is. And the case of or, we're eliminating this case. We're saying that if A is true, then we return true. So we're eliminating the top two cases, and the result is going to be the value of the second operand. So that is as we would expect. You'll also need to rename those guys. So let's see. Basically, those can be taken out and put down here. And we can do it like that. I'll rename these guys to LHS val to be a little more explicit. And that should be B. And let's see. Where are we? Is there anything else I can verify before I go back to the compiler? No, everything is more or less as I'd expected now. So let's go to see what the compiler is telling me. So line 1027. This expression has a sourced value type. So what do we do? Oops, just a second. I'm not sure if the webcam is meant to stay on when I click be right back. I mean, not such a big deal, but that might need tweaking. So, yeah, not sure how to fix that at the moment. Oh, yeah, that makes sense. I mean, kind of makes sense. Type bool cannot be dereferenced, so I guess we'll just go like that. And yeah, that is very true. We'll need to do something about that. Because what are we going to do when we don't evaluate the right hand side? I'm not sure. So partial equality might be missing for binary op. Let's take a look. That is in AST, I guess. And yeah, Yeah, I guess we can derive the definition for that. Cool, that's most of our errors sorted. And so how do we resolve this last one? I think we also want to, do we want to change this to be explicit about where the error is coming from? Well, no, as long as it's unique within the function, then I think we're okay. Although this is specifically referencing the function that failed, so maybe I create a new function or a new error variant for that. No, I think that it has such a unique name because it's being used in the eval function, which is huge. So all the exit points need to be very clearly named. So I think we're okay here because again, we're all the exit codes here are unique and distinct. So how to handle the right hand side here, or that could fix it if we introduce a new variant. Where is this being used? In two places. I guess I can take the RHS here. And this would be invalid boolean operation types. And this would be an option value. Is it called option in Rust? Jeez, it's been a while. Like I said, so yeah, it's option. So we'll go back and and this needs to render the type though. Actually, maybe I just do it like this. Yeah, and I think that works. And then down at the bottom, I can just do the binary operator type. And then I can get rid of that because it's no longer being used. And that's about it then. Can get rid of that line. Actually, I need to reference the fact that it's a boolean operator. So let's try that. Do I have to do .v down here as well? Okay, interesting. So we have it compiling now, but we have a lot of failures. So let's see what's going on. Unexpected operation. I wonder what is causing that. And I guess that's the same for all of them. Unexpected operation, unexpected operation. Yeah, seems to be the case with all of them. So let's see, we'll go to the binary operation call site, and we'll also go to the apply operation function. So here we're checking, if it's and or. Let's try that. Cool. That is what we expected and wanted. So let's get back to the tests. Oh, we have some suggestions as well, which is nice. So 540, we can remove that. 1037, we can remove the return and just do OK like that. And this function's a little messy, a little verbose. But it's also kind of all that's needed. Now, that allows us to write this idiomatically in the way that we want. Now, one thing is that it does somewhat enable the standard JavaScript behavior where you can essentially initialize a value based on defaults. Is that possible? How does that go in JavaScript again? So if we have something like input, which we don't know the value of, we'll often do this in JavaScript. But that's actually still not. So we'll do, we can do something like that, but actually that won't be possible here because input has to be a boolean value. So actually that's not too bad. So this just allows a bit more, handling that's a bit more idiomatic based on the not yet defined idioms of this language, but this is expected to be pretty typical. So we'll go ahead and add something like that. And we'll use strings here just to be particularly explicit about it. Do we want to add this in features, operations? Now we don't necessarily want to hide, shall we say, ill-formed, so to speak, expressions like this, but in the interests of making the language at least a bit easier to use, I think it's beneficial overall. I have two sections for booleans. So let's shrink those. are there any other bits to update? Oh, the version, I guess. Do I bump the version when I make feature changes? I think I do, usually. Let's see. Browser window. So when I implemented that, yeah, I did a version bump. Oh, but not not on the patch version, but on the minor version. And yeah, that's basically ready to be put into a commit. Oh, I've got a white space error there. Oh, and above. And we'll add that as add support for short circuiting boolean operations. And we can go back to the Scratch file. And that does need to be backported back to the original C language, but you know, that's all right for the moment. And yeah, I think that's maybe a good place to wrap up for today. You know, a nice little bit of work done, nice simple feature to kick things off again. And so yeah, that's a wrap, I think. So thanks very much to everyone who checked this out. again, hope everyone is doing well and gearing up for a nice 2026. And yeah, see you again soon. Bye.